Good afternoon, faculty and classmates. My name is fespin1, and I will be presenting my senior project, the Soccer Accuracy Trainer. The Soccer Accuracy Trainer is an attachable and detachable device for shooting and passing accuracy in soccer. When attached to a soccer goal, as can be seen in the middle and right side pictures of this slide, it encloses two separate 2 by 2 foot areas both at the bottom and top corners of one of the sides of a soccer goal. These two corners are the highest percentage scoring zones in the game of soccer. Each of these zones incorporates sensing fields for ball detection made up of an array of photo eye sensors. When a soccer ball passes through these zones, the photo eyes trigger that corner's corresponding LED strip lights, which proceed to flash 5 times, signaling a goal has been scored in the targeted area. There are multiple features that the Soccer Accuracy Trainer incorporates that make it different than other similar products on the market today. Similar products on the market today are made of materials such as netting and PVC, take up the full area of the soccer goal, not allowing for the use of a goalkeeper in training, and often need to be reset due to the constant impacts and the lack of rigidity. How is the Soccer Accuracy Trainer different? Integrated ball detection system. It allows for a wide variety of training scenarios, both goalkeeper in and out of the goal, and it is made of durable materials such as steel. The manufacture of the trainer consisted of a variety of machining processes and tools used. Here you can see a few of those processes being done, such as cutting slots into 14 gauge, 3-inch square steel tubing using a Dremel with a cutting wheel attachment. In the middle picture, you can also see one of the CNC plasma cutting operations that also took place while cutting the 11 gauge steel that was used to make the adjustable base in the picture to the left. Raw materials that were used in the duration of this project were 16 gauge mild steel sheet, primarily used for the paneling and sensor brackets, 14 gauge 3-inch square steel tubing for the main body of the frame, an 11 gauge mild steel sheet for support components such as the adjustable base and also the frame arms. All the technology used in this project comes together in the same circuit which controls the ball detection functions for both the top and bottom corner scoring zones. This system is made up of 8 diffuse photoelectric sensors which are triggered by a soccer ball crossing their field of view, which in turn sends a current through the data wires to a pre-programmed Arduino Uno. That then triggers the LED strip lights that border the sensing field that was crossed to flash 5 times, signaling that the targeted area was hit. This circuit is powered by one single 12 volts DC rechargeable battery. On the left side of this slide, you can see a picture of the test circuit used to verify proper functionality. The picture on the right shows one of the ball detection zones after having been crossed by an object. After all the Soccer Accuracy Trainer's parts were manufactured and its frame and adjustable base were welded, the assembly process began. First, a rust-resistant coating of paint was applied to all external parts. A metallic blue for the panels, an adjustable base to match the nylon webbing strap used to secure the device, and a silver gray working finish for the main body of the frame. After that, the LED strips were adhered in their respective positions and their wires were ran through the frame. Next, the electronics panel assemblies were put together and fastened into place, running the wires from the photo eyes through the frame as well. Lastly, the adjustable base was placed into position and fastened using a quick release pin for ease of use. Still left to do is to install the proper size junction box to the frame and to wire the circuit together once the Arduino is delivered. The evaluation of the project's objectives took place in two separate locations. A lab room in the Engineering Technology Department was used to test the functionality of the soccer accuracy trainer's integrated electronics. The soccer field outside the St. Benedict High School in Cordova was used to test the project's rigidity, resistance to corrosion, and impact resistance. As you can see in the pictures, the one on the left shows the setup that was used during the testing for the functionality of the electronics. The picture on the right shows the soccer accuracy trainer attached to a goal right outside the soccer field. On the bottom right corner of this slide, you can see two links to YouTube videos depicting each ball detection zone of the project functioning properly after a test circuit was connected. So the current status of the soccer accuracy trainer is actually currently waiting on the delivery of the Arduino Uno for the circuit to fully be wired. The junction box must also be installed, and then the integrated technology test to be performed in the intended setting of a soccer field must be tested. Future plans for the project include an overall weight reduction to the whole device by incorporating the use of lighter weight materials such as aluminum. Future plans also incorporate the design of a feature that allows the trainer to be more easily portable and stored, such as being collapsible towards the center of the frame. Ball speed calculation is also a feature that could be in the next iteration with a LCD display on the outside of the junction box to display the speed of the ball. In conclusion, the project serves as a successful proof of concept. The objectives have been met, or at least been proven to be viable. Plans for future iterations of the soccer accuracy trainer have been stated, and documentation for all the project information and the recreation methodology has also been stated. Any questions?